The first two chapters of this course are a review on algebra and pre-calculus. The first chapter, Chapter A, is an algebra review, and Chapter 1 is a pre-calculus review with a little bit of calculus at the end. But in Chapter A, we are going to review our important algebra skills that are going to be very crucial to our success in calculus. Our first topic is the real number line and order, which is section A.1. So in this section, we're going to talk about the real number line. We're going to review interval notation. We're going to solve inequalities and see how interval notation can be used to represent the solutions to those inequalities, and then also introduce our economics applications, which are going to come up in this course a lot. In this class, we are only concerned with real numbers. Real numbers are numbers that are not imaginary. Imaginary numbers are things that involve the square root of a negative value. You might remember the little I from high school. So if we ever come across a situation where we have an imaginary number as a solution to something in this class, we can just ignore that. As a little bit of a reminder about what real numbers are, here's a bit of really brief history involving numbers. The number system began with the natural or counting numbers, which you can see in this diagram is represented by the letter n. The first numbers that came into use or existence or discovery by us were these numbers because we needed them to be able to count items. Then after that, a long while after that, we added in the number 0 into these natural counting numbers so that we could represent the concept of nothing. Then after that, we needed to represent things like debt. And so along came negative values, and together the negative values of the positive numbers, along with 0, represent a number group called the integers. A long while after that, ratios, relationships between numbers, or fractions, which represent parts of whole numbers, came into use. So anything that can be represented as a fraction or a ratio is considered a rational number. These were actually numbers that people thought were very, very spiritual, the answer to the universe. And when the irrational numbers were discovered, people got very, very confused. And so irrational numbers, though, do make up half of the real numbers. Irrational numbers are anything that do not terminate. They are non-terminating decimals with no pattern. So you might remember the number pi, or e, or the square root of 2, or any number that you can write down as a decimal that does not repeat or have any kind of pattern to it. This diagram here is very misleading. There are a whole lot more irrational numbers than rational numbers. In fact, so many more irrational numbers that if you were to actually make this picture accurate, you wouldn't even be able to see the square or rectangle here that is representing all of the rational numbers. We like to use something called the real number line to provide us with a way to organize the numbers, the real numbers at least, and we like pictures in math. So the real number line is the first way that we can organize numbers. It provides us with a conceptually perfect picture of the real numbers, meaning that every point on the real number line corresponds to one and only one real number, and every number corresponds to one and only one point on the real number line. The way that we draw the line all solid and kind of filled in gives us a sense that there's always a number between any two numbers, and so it is actually like that. It's what this is saying here, where every number corresponds to a point and every point corresponds to a number. Two important features of the real number line is that it is ordered, meaning that as you go from left to right, the numbers get larger. Any number that's to the left of a value is smaller than a number to the right of it. Another reason that we like the real number line is because it's kind of a graphical or pictorial way to help us to represent solutions to inequalities. To represent solutions to inequalities, we use a notation called interval notation. Intervals represent a range of values, a range of numerical values. So we can have several different types of intervals that are demonstrated in this chart. The first type of interval that we can encounter is called an open interval. This basically just means that the endpoints of the interval are not included. So we have a few different ways that we can represent these kinds of ranges of values here. So the interval notation for the range of values that is between, so this is a number line here, so between the number A and the number B, if we want to talk about all of the numbers that are between those two values, then we could graph it in this kind of number line picture where we make a solid line here between A and B, and then we can put an open parenthesis at each of the endpoints to indicate that we're not including the endpoints. Another thing that is very common is to put an open circle at the endpoints here like that, and that would be meaning the same thing. Interval notation is preferred, and the way that we would write that in interval notation looks like this. It is parentheses A, comma, parentheses, B, parentheses. This down here is also equivalent. So we have three ways. We've got interval notation, we've got a picture, graphing, and then we've also got what is called an inequality. So these three things are all meaning the same. All values between A and B, not including A and not including B. If we do want to throw in the endpoints, let's say A and B, then this is what we call a closed interval. So this is when the endpoints are included. We call it, we're just kind of closing off the interval when we do that. So numbers between A and B, we still put the starting number here in interval notation A and the ending number here in interval notation B. And then instead of parentheses, we put a kind of bracket or brace. We can draw this on the number line in the same way, except instead of the parentheses, we would close it off with a brace or bracket. You might even see this with a closed filled in circle at each of the endpoints. In terms of inequalities, this would be the representation of that. So we'd say A is less than or equal to X, which is less than or equal to B. So just throwing in the equals at the endpoints here means that we close off the intervals and include the endpoints. We can have intervals that have a mixture of these two things, so we would call these neither open nor closed. Intervals that are neither open nor closed. So maybe you just want to include one of the endpoints but not the other. So here's our first example. We're going to include the endpoint of B, but not A. So this is all numbers between A and B, including B, but not including A. On the other hand, we can have the other kind of neither open nor closed interval, so all numbers between A and B. Here we can include A, but not include B. The last type of interval is called an infinite interval, and this is when we just want to talk about numbers that are bigger than a certain number or numbers that are maybe smaller than a certain number. So these are infinite because there's no sometimes starting and there's no sometimes ending. So there are 5 types of infinite intervals. We could have all numbers that are less than a certain value. So if you want to talk about numbers x that are less than a certain number a, then the way that we would draw that would just be, okay, a and all the numbers less than that are to the left. But if we don't want to include a, we put a parenthesis, or maybe we put an open circle there. In interval notation, which is what we want to be comfortable with in this class, we need to bring in this symbol of infinity in order to describe this behavior. So since there's no ending or starting point on the left or smallest number, the way that we notate that is we're going to put a negative infinity as our lower point here, and then to a and not including a. So we have an open parentheses. If we have the same type of behavior, but here we can have numbers equal to a in our interval, then we do the same thing, but here we just are going to close off that endpoint and make that a brace instead of a parenthesis. If we want to talk about numbers that are greater than a certain value, for example, we'll just using b again here. If we want to talk about all numbers that are bigger than b but not equal to b, then again we can have an open circle or parentheses here. And because this is unbounded this way, we don't have a largest value that this interval has, then we use the symbol positive infinity for the upper bound there. If we want to throw in that x can equal b, if we want to close that part of that interval there, then we would just close that parentheses into a brace, and there's our interval notation for that. Our last type of infinite interval is all real numbers. So if you don't have a starting point or a lowest value and you don't have a highest value, if you want to talk about all the real numbers, then in interval notation, we would write that as negative infinity, comma, positive infinity.